Hello everyone, welcome to the Raise.dev Hacktoberfest Help Desk. My name is Joe and I am your host for the show tonight. If you are new to the Hacktoberfest Help Desk, the Hacktoberfest Help Desk is your resource to get all the help you need to land your pull request this Hacktoberfest. If you're new to Hacktoberfest, this is an opportunity for you to get started with open source, find some new projects to contribute to, and we're coming to you live 3 times a day on this show, giving you tips and tricks on how to actually complete some pull requests and contribute to new projects, helping you find new projects to contribute to, and helping you find new ways to contribute to those projects. And so we have special guests every day who are showing off their projects, talking about their code, that kind of thing. And that is what we've got going on in this show. We've got a special guest here tonight who will be showing us an open source project that they work on, and in fact that I work on as well. Very fun. And also we'll be talking to them about, this is going to be our first Java show, weirdly, that we've gotten 55 shows in without having any Java. But there'll be some Java. We're going to talk about GraalVM and we'll get more into that in a minute. Before I bring on our guest for the day, let me get through the house administrivia and the various things you need to know. As I said, we are here to help you, which means you can ask questions in the chat at any time, and we will do our best to answer them as we go along with the show. If we don't answer one of your questions immediately, do not panic. We will answer it before the end of the show. It's just we might be in the middle of a topic or something like that, and it's sometimes hard to find time to ram things in, but we will get there. Do not panic. The other big thing to note is if you want to post a link in the chat, you're very welcome to share links to resources or things you're working on. Just be aware there is a moderation bot who will delete your link and time you out. So what you need to do is at RaiseDevs in chat, let me know you want to post a link and I will permit you to post a link. And that warning goes out especially to Wojtek, who may have been set up for failure. Hi Wojtek, thanks for joining us. So if you want to post a link at RaiseDevs, let me know you want to post a link and I'll add you to the permit list so you don't get caught by our spam bot. So the other thing that I need you to know, as I said, we are coming to you live 3 times a day, every day in Hacktoberfest, which means there are still 3 days left after this one, Wednesday, Thursday, Friday. Still 9 more shows for you to catch, and that's a lot of shows. How on earth will you keep up? Well, you can go to twitch.tv RaiseDev schedule to find our schedule for the week, to find out all of our special guests. Hang around at the end of the show, and I'll do a little schedule teaser for you and talk about the shows we've got coming up and who we've got coming on for the rest of the show. As it is the last week of Hacktoberfest, we've got some really big stuff planned, especially Friday night show is going to be wild, and I see Ramon is already in the chat. We've got Ramon with us tomorrow, so hang out at the end of the show and I'll tell you about those shows we've got coming up. So the final thing from me before I bring on our guest and we get going, if you haven't heard of Raise.dev, we are a service to help you level up in your developer career, whether you're trying to get your first developer job after a career change or a boot camp, or you're trying to get a promotion or move from mid-level to senior, anything like that. We have expert coaches who will help you get the experience that you need to make that transition, to get that level up. And you can register completely for free whilst you're in early access at Raise.dev. So that is everything from me. Let me bring on our guest for the evening. Please welcome Marcin to the stage. How you doing?
Hi, I'm doing great. Thank you.
Awesome.
How are you?
So, yeah, very well. We can hear. So we did have some technical issues before the show. So anyone in chat, if anything weird happens, let us know and we'll try and fix it in flight. But you sound great right now. Would you like to introduce yourself to the folks on the show?
Right. So, hi everyone. My name is Marcin Kostrzewa and I'm a developer at Enso, which is a great job because it allows me to be creating my own programming language rather than other programming languages, which is like the dream.
For sure.
And yeah, I'm essentially like leading the efforts in the runtime and interpreter area of the whole system. So this is what we'll be talking about, I guess.
Yeah, for sure. Absolutely. So for the folks who are in chat, let me lay out how we're going to do the show. We're going to basically jump straight into things. I'll start talking about Enso and Luna, and we'll get into the difference between those two in a moment. As Marcin said, Marcin works on one particular end of the project, so we'll be focusing a lot on that, and we'll be seeing a lot of the cool magic going in on there. But we'll make sure that everyone understands the context of, I guess, the project before we get into how it all works. So shall we jump straight in and start talking about what is Enso? Tell us what Enso is.
Sure, let's do that.
Cool.
Maybe let me screen share so I can also show some flashy images that are probably going to look very bad on stream.
Images. Hey Nick, thanks for joining us. Again, for those of you who missed it, Nick was on the stream earlier. Nick works at Dev2 and we're streaming some work on Forum, the wonderful Ruby on Rails app that powers Dev2. You can catch that in our recordings. Okay, cool. So that's now up on the screen. There we go. Cool. So this is there's things happening. There is animations happening. What is going on?
Exactly. Yeah. So what Enso is a programming language that is very unique in that it has a double representation, meaning whatever you write in code is displayed as those flashy graphs that you see here. You are probably working with the product a bit slower than it is showing right now.
I hope so.
But yeah, essentially the idea is that you have those nodes on the screen, and those nodes
Right.
are processing your data.
Sure.
They are doing something programmistic with the data,
Right. Right.
and you have instant feedback, right? So whatever you do, you can right away see what is the result of this operation. And on top of
Sure.
that, this is a double representation language. So
Right.
everything you create with those nodes is also represented as textual code, which
Okay.
is
Which we're
right now
seeing here.
showing here.
Cool.
Yeah.
Yeah.
And then when you are changing the code, you are also updating the visual representation of the language. So
Okay.
what
Cool.
this gives you is this great functionality for like cross-functional teams when you have a lot of
Right.
like data analysts and people that are more used to say Excel than Python.
Right.
Those people can jump in and start working with the nodes instead of using code, because code is scary for non-developers.
Right.
While when there's something more involved, require like
Yeah.
some help required from a developer, the developer can just jump in, and if they need to write some like low-level code to do some step in the processing pipeline, you can just give the developers the tools to do it in code.
Right. Okay, that makes sense. So I guess to like briefly summarize that, the idea behind dual representation is like you have a nice friendly interface for folks who may be less exposed to code, but the code is still there if you have a developer on your team or for whatever reason. I guess like version control is another really good reason to also have a textual representation. Is like there are systems like version control that you can keep that in. Would that be accurate?
Yeah, exactly. Like for example,
Cool.
GitHub is not really used to working with visual
Right.
GIFs, right?
Yeah.
Until we blow up and everyone uses Enso. Well, it's probably going to happen, but
Yeah.
for now, yeah. So
Cool.
when you are doing a pull request, it's much easier to just read it in code for
Right.
now and see what happens in the changes.
Okay, cool. So there's like a million places I want to go from here. So okay, let's start with this. So right now we're looking at something called Luna, and obviously you and I have already said Enso a bunch of times, and the stream we've mentioned Enso. What is happening
Right.
there?
Right. So Enso is language formerly known as Luna.
Okay.
So essentially, we decided to, well, first of all, I think you have hinted a lot in the previous introductions, is that
Yeah.
we decided to pretty much start over from scratch and rewrite
Right.
everything. And also we decided to kind of rebrand, because the Enso name was like better to capture the idea behind the product.
Yeah.
And
also
stuff
Luna
like
is
that.
very close to Lua.
Yeah, also Luna is very close to Lua. That was
Yeah.
a lot of confusion. Also,
Yeah.
Luna is apparently some cheat engine for video games, so that was not great for
Right.
our Discord traffic. But
Perfect.
so yeah, so we
Cool.
are Enso now. But so whenever you hear about Luna, think Enso.
Yeah.
Whenever you think about Enso,
Cool.
keep thinking
Nice.
about Enso. Forget about
Yeah.
Luna.
So we're going to come back to this, I guess, in a little bit, because part of what I want to talk to you today, that anyone who's watched the end of the show the last couple of days will know, is I want to get into a little bit of like the fun of having a reasonably active open source project that you then say, and all this code is dead and we're starting again. So I want to talk about that a little bit at some point. But I guess before we get there, I guess it'd be useful to. So what we're mostly going to be talking about today is the implementation of Enso, because Enso, as I understand it, is not currently yet finished. So that's why we're seeing a website and seeing a graph on the website, because Luna 1.0, Luna 1.9, this one was usable and like was a thing, and then you started the rewrite, and Enso 2. Like Luna 2.0, Enso isn't yet out yet, right? So
So everything you are seeing is coming from Luna.
the old one, yeah.
All the textual stuff I will be showing you later is coming from Enso, and you are not seeing the visual Enso yet.
Right, just the language. Okay, cool. So yeah, let's start on that pin. Like, why would you? What makes you scrap and rewrite a whole project?
Well, so mistakes were made. This is the short story.
Okay, cool.
So, and like when I say mistakes were made, pretty much in every area of the original project, we've made some technological mistakes that made things really hard to scale, and really stopping us from driving Luna to a place where it would actually get adoption from actual users, right?
Okay, so I want to hang on that comment for a moment, just because like saying like the idea of mistakes being made in the implementation of a programming language that stop it scaling is really interesting, because like when you hear that, like, oh hey, something it's been built in a way it doesn't scale, you're talking like, you know, web apps where the architecture and the infrastructure of the servers behind it means you can only send so many requests through it. So like, what does a programming language not scaling mean?
Well, okay. So in the pure programming language layer, it was just slow. Like it was dog slow. It was horrible. So for example, when we implemented data frames, we had to implement all the data frames library in C, and then use like really obscure ways of connecting that back to, which is pretty much what Python does, but nonetheless, we wanted to have like more native experience for that part of the project. So the interpreter was slow, and there was pretty much no hope of saving that.
Right.
Like it would take us multiple years to get to the place that we are at right now with the new implementation. Cool. And then in the graphical interface, there was also a host of technological mistakes. So first of all, if you download Luna 1.9,
which you still can from the site, it is broken as hell.
Yes, it is broken.
Which is my fault, funnily enough.
Moving repositories without checking what will break. But anyway, so if you download using this huge button here, what you actually get is a rebranded Atom text editor. So like for anyone who doesn't know, Atom is the thing that was the editor of choice before VS Code.
VS Code, yeah. It was GitHub's editor. It was, oh my God, I can never remember his actual name. It was defunct. The old CEO of GitHub, it was his pet project, basically.
Yeah, so Atom is a great editor, but it wasn't great for our purposes, mostly because it was pretty slow. So like launching Atom takes time, and the whole experience is like pretty junky. Like Atom in itself, even if you don't install Luna in it, it's pretty slow.
Yeah, and it was made to be extensible. So I guess like building a whole visual language editor in it is like a triumph for Atom. But as you say, I can imagine how that would be very slow.
Well, yes, it was also like so why we decided to do it was that if you are building a programming language with double representation and all of that, it's the assumption was that it would be much easier to piggyback on Atom, which is already a great text editor, and then we just add a single pane with like HTML view of the code, which brings me to the second mistake we've made, HTML. So if you look at all of this, those shapes are not really. Yeah, they are not really HTML friendly. So that was another source of junk in there. And also like we had clients, for example, that were creating their workflows, their pipelines with like 800 nodes on the scene at the same time, and they wanted to keep it this way. Even though like we kind of discourage that, we say you should use
break stuff up.
Can you hear me?
Yeah.
Okay, sorry. So yeah, even though we tried to discourage it, tell them to refactor, they were like, nope, we want to have all 800 nodes at the scene at the same time. And this is SVG. When
Nick just asked that question.
So when you have 800 nodes on the scene, it's like tens of thousands of shapes underlying all of that, and this becomes really slow. Like the IDE would work in like half a frame per second or something like that, which is not great if you want to have like this really cool experience of working with the product. So mistakes on all fronts. Using Haskell for the backend, bad idea. Using Atom and HTML for the front end, also a bad idea.
Awesome. Okay, cool. So those are bad ideas. What were the good ideas? Like, what is it written in now?
Right. So the front end, which I really don't know much about, but
we're not going to be going into the front end today. However, the front end does have Hacktoberfest issues that are open, so you can go check that out. But you know what it's written in at least.
Yes. So it's all written in Rust. It's Rust compiled to WebAssembly, and it's working in WebGL, which is much more difficult to get right. Like HTML exists for a reason, but also it allows us to have this much faster experience, right? Like this 60 frames per second with millions of shapes on the scene at the same time, which is great for data visualization, right? Like if you think about, for example, a scatter plot of like a huge data set, you get millions of points overlapping, doing all sorts of strange stuff there.
We could do for showing the front end. We can go to the dev blog, I guess, and show a GIF. Hugh, I don't think I have context on that. Hugh asked, are you concerned about the recent announcement of the status of Rust Wasm? What is the status of Rust Wasm? What have we missed? I'm
I
assuming
also
Wojtek would have heard this. Wojtek's okay. So in chat is
yeah.
Wojtek. Wojtek is another member of the team who works on the IDE. So Wojtek, feel free to jump in chat with your opinions at any point. You can piggyback the show. We're formally inviting you to be a backseat driver in chat. I'm trying to find a good GIF that we can show people from the dev blog. We haven't blogged about nodes for a little while. We've got lots of searcher stuff. Yeah, sorry. While I'm doing this, carry on. So Rust and WASM, high performance, 6 frames per second, great for visualizations, which so the SVGs are completely gone now. It's all like
it's everything is WebGL. From what I know, there are ways to like embed HTML as visualizations, because like there is a lot of great HTML stuff that exists and we would like to reuse. So you can embed an HTML view as a visualization for your data, but the default mode of operation is WebGL, and like the whole UI is written in WebGL.
Mm-hmm. Oh dang! Thanks for this, Fred Hugh. I'm now going to go have a small existential crisis. Anyway, yeah, Wojtek, have you seen that, Fred? Anyway, so that's the front end, and then the engine side, the compiler and interpreter side.
Right. So I think I haven't touched on that yet. So the original Luna was written in Haskell.
Right.
And Haskell is a great language for some uses. It wasn't a great language for our use. Mostly because, like, if you want to write an interpreter for a language, you probably want to get into some things that we'll get into later, some stuff like JIT and so on. Haskell has none of that, so it wasn't great for the performance. And also it wasn't great. So like one of the core ideas behind Enso is that we want to be able to interoperate with other languages. So like we want you to be able to seamlessly, for example, call a function from JavaScript or from R or from Java right now. That was completely impossible with Haskell. Like all we could do was some very primitive CFFI, and CFFIs aren't very user-friendly. So in the meantime, a small little project called GraalVM and the Truffle framework on top of Graal, they really matured. So we started the rewrite over a year ago. It was July last year. And at that stage, it seemed clear that Graal is going to exist and give us a lot of great capabilities in the engine. So stuff like JIT compilation, stuff like language interoperability, all of those great things that we always wanted. So on this front, the decision was even easier. Like there exists a framework or like a runtime that gives us everything we want for the language, or almost everything.
Cool. Okay, so for folks who, to back up a little bit and go to a little bit high level, for the folks in the chat who are not as familiar with the systems that their languages run on, like what is GraalVM? Like what is a VM in the context of Java, and why is Graal important?
Right. So GraalVM is a JVM, first of all. And JVM is a thing that runs Java, essentially. So Java compiles to some intermediate representation called the Java bytecode, and that is then interpreted by a JVM. So under the hood, like Java, you could say that Java is an interpreted language. Now, Java is also JIT compiled, so just-in-time compiled. And just-in-time compilation is the process of kind of compiling your code to machine code on demand at runtime.
Right.
So you have an interpreted language that you are then compiling to machine code whenever you notice that some function is called frequently, that you can do some optimizations to it, and so on and so forth.
Cool. Okay.
And Java had this system for a very long time.
Yeah.
The standard JDK always, well, not always, but for like 15 years or something.
I remember JIT being pretty much the first compiler concept I ever learned about because of all of the fuss about when JIT came to Android. Just how big of a thing that was. It was like, oh, okay, that I guess this is how I'm learning about compilers. That's great. Anyway, sorry, completely random tangent.
It also completely upended the whole like standard distinction we always had, right? Like there was interpreted languages and then there was compiled languages, and then JIT comes along and we're like, oh, okay, so I guess my language is half compiled, half interpreted now.
Right.
So that's pretty cool. So yeah, Java had a just-in-time compiler for a very long time, and then what GraalVM is a re-implementation of that just-in-time compiler in Java. So the whole thing was written in C, and then GraalVM is a project that rewrites it into Java. Now, why is that important? This is important because this allows other Java developers and other programs working on the JVM to call into the compiler. And on top of that, the Truffle language implementation framework was built. So I think it started with Ruby and JS. So it was this idea of like bringing Ruby and JS into the JVM world with very good performance. So they are essentially piggybacking the JIT system that Java already has, and they are re-implementing other languages in this Truffle framework. They are re-implementing other languages to be much more performant and also interoperable between.
Interesting. Themselves. Cool. Vortex now talking to Hugh about the WASM deprecation that you shared with us. Okay, cool. So I guess you gave a little example earlier of like places where a programming language implementer might use interop, like, calling back to a previous language. And of course, I think most programmers probably have an intuition that like, every advanced programming language has to be built with a programming language, so it's calling back to something else. But can you give some examples of or talk a little bit about why interop and the kind of interop offered by Truffle is particularly important if you're trying to write a language?
Right. So, the normal word is that you have some host language, right? Pretty much every other compiler is written in C, and that means you can import functions from C or C++ and call them from your language. Which is really used for very primitive libraries, and if you need this extra performance boost, you can call into C and use that. Now, what Truffle does is a step further, because it's not just about calling the host language. So, for example, for Graal, it's not just about calling Java. It's about calling all the languages that are implemented inside this VM between themselves. So I think I can show you some.
Yeah, let's do it.
I can post some examples from the Graal website.
Cool. And in the meantime, I'll quickly throw up a screen. While you're looking for that, I'll throw up a screen share and show some Enso GIFs. So this is a GIF. Let me zoom in on that. This is a GIF from new Enso. As you will see, it's not quite as pretty as the GIF you saw on the Luna site because it's not done. But this is defining a node. So nodes aren't big change. Nodes aren't circle anymore. They are just basically the expressions that you define, and this is showing the dual representation. So this is in WebGL rather than SVG. So as that's being updated, it's coming down through to there. And then this is our built-in documentation viewer. Let me find, here we go. This is playing around with selecting parameters in a expression and bringing the connections out. So yeah, that's kind of what it looks like nowadays. These are all GIFs from our dev blogs. These are all parts of a larger system that will eventually become functional. Our latest edition has some look at the visualizations and stuff linking together. This is collapsing nodes. So this is the way that you refactor in Enso. Basically, you can define functions in Enso rather. You can select multiple nodes and collapse into one. So yeah, cool. So you were looking for some examples.
Yeah, I already found them, I think.
Perfect.
Yeah, okay. So, so what you can see here is that, can you see it yet?
Yeah.
Okay.
Here you go. You might need to... Oh, no, that's fine. There's weird screen proportions. You've got a lot of blank space on the left. I guess zoom in a little bit and that might fix it. Yeah, that's better. Perfect.
Is this better? Yeah.
Yes.
So this is the mind-blowing magic of Truffle. So this is a piece of JS code, and you can see that they just call polyglot.eval r, and then they evaluate an expression in C. Sorry, not in C, but in R, into JS.
Okay, cool. Right.
And so this expression in R is creating an array, and then automatically you can just use that array in JavaScript as though it was a JavaScript array, right? So there is no data copying under the hood. There is no data marshalling. There's just a special protocol that kind of if you know about Java interfaces, it's kind of like that. Okay. That allows you to expose this sort of functionality to all the other languages. So yeah, all the languages are interoperable between them. So you can see that from R, you can call JavaScript. From Ruby, you can call JavaScript.
This is wild.
and this is great. So to come back to the question of why is this even important? So what, like if you look at the whole programming languages landscape right now, there's a lot of specialization, right? Like there are languages that are good at a thing and bad at another thing, or not even languages, more like ecosystems, right? So for example, let's say you want to do something with like a web application, right? You would probably use Java or Ruby or like Scala or Ruby, pretty much. Those are the two choices if you are building a web app. But then you want to do some data science on top of that, right? Like you have an application like, I don't know, Prisma or something like that will do some data science magic under the hood. There are no good libraries for data science in Ruby. I'm sorry if there are, and I'm offending someone, but
I mean, it's not known for it. Like you typically hear R, Python, Julia, right? Yeah.
I have never found a good data science library in Ruby. There are great data science libraries in Python, where the web development word is not so great. So what you can do with Truffle is you can write...
Django devs in the chat, calm down. But yeah, so yeah, you can, in Truffle, you basically use whatever language you want for the time that you need it.
Yeah, right? Like you do your webby stuff in Ruby, and then you do your data sciencey stuff in R, and then like no data copying. It's all inside the same runtime, so it's pretty much like you are using one language, except you are using multiple languages.
That was going to be my next question. Like, how does that perform? And also, I have so many questions about like dependency management. like dependency management is a nightmare when I'm working in one language ecosystem. Now, like if I've got like a program that needs to interact with like 4 different package managers, like how is that even a thing that is factored into this? Does that make sense?
Yeah, not really, unfortunately. So like this is like the languages themselves, they come with some sort of dependency management.
Right, so it's for like the inbuilt functionality, basically, not like the whole ecosystem.
Well, you can install any library. Not all libraries work on Truffle yet, just because like the languages are still like not all of them are created equal, not all of them are yet feature complete. So for example, like I think 2 days ago I've seen a blog post saying that Ruby is now Ruby passes 97.5% of the specification tests. So anyway, there is no solution for, as far as I know, there is no solution for package management yet. And yes, this is probably going to be hellish, and this is a challenge that we will have to tackle head on sooner than later.
Sure.
And I'm not excited about it, but yeah, it's a thing that we'll need doing.
Yeah. So I guess my next lot of questions were like, do you have some examples of where this is being used in Enso? And I guess that will kind of bring us into looking and diving into the Enso engine. So do you want to is this a good time to jump off into that and show some Enso code? And actually, we had a question from Hugh, which also comes into this, which I guess you'll end up showing us, which is like, in the visual. So the reason I think you can answer this is he was asking like in the visual language, does it have a right to left execution module where the most node is executed first? And I imagine that's not the case because the dual representation. So that would make absolutely no sense because the text wouldn't know anything about the orientation of the nodes.
Yes, exactly. Cool. So it executes top to bottom in the textual file.
Right.
But so one important thing is that Enso is functional, so you really shouldn't care that much about the order of execution. Right. Or at least in the node-oriented world, you shouldn't. Like if there is a data dependency, you should have a connection saying, do this first, then do this, and so on and so forth.
I think Wojtek has set the record for the most words ever written in the Twitch chat.
Oh my God! Yes. People are having an actual discussion in the Twitch chat.
It's a miracle. It's a miracle of Twitch. Cool. Yes. Let's dive into some Enso.
I'm wondering if the Twitch chat has code highlighting, because that's going to happen soon with voice.
Actually, that must be. I wonder. I mean, they don't support Markdown. That'd be cool. Hey, user temporarily suspended. We are live before you ask. Welcome back to the show. Thanks for dropping by. Cool. So yeah. What would you? Where's a good place to start with the... Oh, I'm going to have to put your screen up again. So I'm very distracted by chat. There we go. Poof. Okay, that's going to need some zooming in. There we go.
Right. So you asked about how this is used in the... Oh my God, this is one long line. how this is used in Enso. So right now we only like really support Java.
Yeah.
There are some ways that if you download Enso today, there are ways to get it other languages, but those are not officially supported. Like I don't give you my blessing to do that, but there are ways. But Java is like officially supported now, and you can see like this is a very seamless sort of interoperation. So at the top of the file, I'm just writing polyglot Java import, and then I just give a name of a module that is in the Java standard library. So like java.time.duration, this is something that every JDK will have when you download it. And I'm importing that as Java duration. And then you can see that I'm just calling method on this Java duration as though it was an Enso object, right? So there is no like special syntax of, oh, now I'm going to be calling a function that comes from Java. No, you just pass it. Like the only thing is that you pass the arguments in a vector because of like slightly different semantics. But yeah, it looks like an Enso function call. And most of the Enso standard library at this point is built this way, mostly because I would rather build it this way to test the whole system pretty much, and also to provide examples to the users, right? Like how do you so see this is the great thing. Like even when we are creating the standard library and I forget to add something, I can just tell a lost user that is like, oh no, I really need this functionality. Great, just import.
So if you know how to do it in Java,
yeah, like it probably exists in the Java standard library or in some library in Java. So just import it and wrap it for yourself. That was one of the biggest problems of Luna, by the way. Like it was really non-extensible. So we lost a lot of people bounced from the first encounter with the project because they wanted to do something
they needed.
It wasn't possible to do. Implementing that in pure Luna wasn't really viable. Implementing that in C would be a pain in the butt. Like who wants to implement something in C nowadays? So yeah.
So you'd have to fall, if you were doing this without this like really easy interop, you'd have to fall down to the host language in order to define like the low level functionality for the standard libraries.
Yes, exactly.
Cool.
Or even have it built into the interpreter, which is even worse. So like we are kind of trying to, of course it's unavoidable, like some functionality you have to have built into the interpreter. But we are trying to minimize that set just because like adding a new function and having to like bump the interpreter version, this is not a great experience, right? Cool. So we are trying to have as much of this built with tools that are available to the users as possible.
Okay, cool. So this is where I have to crack up my notepad because I have a million questions. I need to make sure I don't forget them. So I have two main questions at the moment, and you decide which you want to start with. I think it'd be good to start with talking about Enso, the language itself, and like how it works and what it looks like. Because the reason that I think I want to talk about that is like most programming languages, when they're defining their syntax and how they work, don't also have to think like, hey, this has to make sense in the visual context. So I'm really interested in like those design challenges and like what that has ended up making Enso look like. And also, actually, it's a functional language. So for some people who haven't had the delight of using Haskell or a Lisp or something like that, they might not know necessarily what that means and what effects that has. So can you describe the language for us a little bit, or like show us some examples of things that I guess are unique to the language?
Sure. So first of all, purely functional language. What does that mean? It means it's a language where there is no mutable variables, first of all. So like you cannot, for example, write a loop like you would in Java or any other language where you just go for I equals blah, I plus plus. Like you can't really do that. Most of your data is immutable. Most of your data. So for example, if you insert something into a list, instead of modifying that list in place, as would be the case in most languages, you get a new list back with your element inserted. Now, why is that important? Well, it's important for the readability of the visual representation. So this is precisely what you asked about. In the visual representation, when you have a bunch of nodes, like something is using another variable and then using this and then using that again, the visualizations kind of allow you to take a snapshot of what the state of the system is. Now, if that state was mutable, this would be much harder or straight impossible to do, right? Because like if your variable keeps changing 1,000 times over the course of the function execution, what is the value that you show to the user?
Right.
This is kind of a problem that Jupyter notebooks have with Python, right? Like you can override your own variables and then you like run your cells out of order or do something like that, and like your runtime can get into a garbage state just because you messed up the order of execution. So with this, we kind of make sure that things are mostly immutable. They will behave well in graphs.
Right.
I'm saying mostly immutable because unfortunately, computers operate on mutable memory. Fun fact. So this is like like most runtimes are not overly happy about immutable memory. So there is a bunch of like tricks. Even in the standard library, there's a bunch of places where like I would use mutable memory, but then hide it behind an immutable API. So that like when I'm implementing the standard library, I'm mostly thinking about like the users that will be using it in the graphical interface. So I have some like escape hatches for the like low level mutable stuff that people may want to use. But the user facing, like the data analyst facing, let's call it APIs, they are going to be nice and immutable, and they don't have to think about, oh no, what is memory?
Cool. Okay.
Right? Because like even this is a tricky concept to a beginner. Like, what even is memory? It's just like there's values, right? There is no memory.
Right. The whole like model of like we have boxes that we put things in doesn't hold up in that paradigm.
Yeah, exactly.
Interesting. Okay, cool. So immutability is one thing, and then I'm trying to think of where to go to next. So we have on the screen, you have some type definitions. Now I know the types. There's a type system described.
Yeah. So this is a time constraint pretty much. So like we want this language to have a type checker. We want it to be safe and also to guide you through everything you are doing. At the same time, there's only so many hours in a day. And we've just decided to start with a very good runtime for a mostly dynamic language, something that like has pretend types mostly. So for example, if we go to the vector file, you can see that I'm writing some pretend type signatures. They are going to be displayed in the IDE. So even those are a great value added to the user because it's going to be displayed. It's going to tell the user something about what they need for that function to run. But at the same time, we just don't have time to implement a blown type checker yet. So yeah, it's a dynamic, statically typed language.
Yeah. Hugh was asked, does Enso have higher order functions and how are those represented visually?
Yes, it does.
Yeah, Wojtek already said monads in chat, so we're inevitably gonna have to get to that one.
He did?
Yeah, he did. So yeah, sorry, I completely interrupted you. So it does have higher order functions.
Yes, it does have higher order functions. How are they represented visually? Well, just as values, right? So like you have a data dependency. For example, on one node, you can have a vector of numbers, and on another node, you can have a function as a value, and you just pass the value from to the next node, which is like, for example, map. So yeah, like speaking about higher order functions, like this is the zip function right here. Right. So this takes a higher order function. You have a zip of one vector with another vector, and you add them together.
And then the function you're applying. Yeah.
Yeah. The function is plus. So on nodes, you would just have this plus as a value, as a separate node, and you would connect it into this node as a data dependency, right? Because in functional programming, like the whole thing is that functions and data are the same thing. Kind of.
Right. Very cool. Neat. I'm trying to think of a good question to ask about syntax. So I'm just going to so obviously this type of syntax for people who haven't seen an ML family language before is not necessarily going to be, I guess it's going to be more familiar nowadays thanks to TypeScript. But say, for example, that zip function, just for people who haven't seen an ML language before, like what are they looking at here with like zip, colon, and then this type signature and then so on from there? Like how would you relate that function definition to what they might see in, say, like a Java or a Ruby or a JavaScript? Does that make sense?
Yeah, sure. So a colon is a type ascription. So we are defining a thing that's called the zip, and the thing is a function, right? And other than just saying, okay, so zip is a function, it takes that as an argument, it takes function as an argument, and then it does something in its body. We also give it a type signature to kind of guide the system, to tell it what kinds of inputs is it expecting, right? So the arrow operator means it's a function that takes something and returns something. So in this example, we have a function that takes a vector, and then it takes another argument, which is itself a function, right? Because we have those parentheses. So the second argument is a function that takes two things of type any. So essentially, two arbitrary values, returns a third arbitrary value, and then the whole thing returns another vector. So this is the syntax for assigning types to values.
Cool, awesome. Hugh complimented your Markdown and has just gotten a tutorial on how our documentation system works.
Right, yes. Maciej Ichat is the author of the documentation system parser and all of that, so yeah.
Which is super cool. And you might have seen it in that screenshot I showed earlier. It recently hit the dev blog. I think it's in the September 11th edition when that made it out, but it's really neat how it comes up just in the IDE.
Yeah, like the whole idea behind it is that you can display it in the IDE, kind of like if you ever used Excel or Google Spreadsheets. When you start typing in the formula window, you get hints, and those hints have like inline documentation telling you like how can you use it. There's also examples, there's stuff like that, right? So we are kind of going in that direction so that this is sort of documentation as code, in a way, because you can paste it as a.
Yeah, it really speaks that you're a Vim user, that you referenced Excel for that and not like code completion in VS Code or an IDE. Like you get that in modern text editors nowadays.
See, I'm using IntelliJ, and IntelliJ does not do that. Like,
oh really? Okay.
It gives me hints for the names available, but I don't think it displays documentation by default.
The VS Code will definitely do that in some cases now. I know the only reason I know that is because when Ara and I were working on the GitHub Actions, we were both just like JavaScript, and luckily it displaying those hints got us through. Cool. Okay.
Sorry. I'm glad.
So those are the questions I had, I guess, about the language. Was there anything else about like the language itself that you wanted to touch on before I start asking you about the life of a standard library writer?
Well, I don't know. It's just a very neat little language. It should be like the hope is it would be understandable. Oh, you can see some mutable memory poking out of here.
Unsafe, not set out.
We don't talk about that.
Just hide it all under the unsafe rug.
Yeah, exactly. Also, it's object oriented, so you can see the dot operator here. Do
you want to talk about uniform call syntax?
Sure, we can talk about that. Yeah. So essentially, in Enso, like when we have the code like this, that this dot to array, we can also write to array this. So there is no difference between functions and methods. Essentially, calling a method is just syntax sugar, and this is done purely because it just parenthesizes better, pretty much. Like it's easier to write a chain of dots, particularly with another like controversial feature. At least I know it's still some controversy with you, Joe. The precedence of the dot operator. So like the way operators
significant white space in line.
Yeah. Yes, but
I understand it. Yeah,
it's actually pretty great, right? So like if the operator is not non-spaced, this is kind of like this would be parenthesized, which allows you to really trim on the number of parentheses that you have to.
Yeah. And it's again another example of like a place where the necessities of the visual language have like fed down into the textual language. So the reason I wanted to ask about the uniform call syntax, funny enough, actually, I had a question from a friend who's just learning Python yesterday about the difference between like I'm gonna have to type this out, but basically about the difference between like string, where string is like the actual class dot length versus like a string dot length and then fed a parameter. Sorry, the other way around. Calling dot length on a string versus calling it on the class. And I was like, this is a great example where Python should just have uniform call syntax.
Yeah, and also in Python, like on most objects, you have just straight len, and then in parentheses you have you pass the object, right? So there is no dot at all. So so this is an innovation that I was opposed to it. Luna didn't have it. Wojciech, who's in chat, was very vocal about we need this. And I'm actually glad that we do, because as you said, it's very confusing to a novice, like why is there a dot, why is there not a dot, and also to a library author, right? Because like if you are a library author, you have to constantly keep thinking about, is this a function, is this a method, like how like when I guess this is kind of feeding into how do you write a standard library, but one thing you do is you keep thinking about how is this API going to be used, right? So like, does it look better with dots? Does it look better if it's called like functionally, let's say?
Right.
So yeah.
And that's the kind of leads into the end of that discussion on that like Python, like do you use len argument or do you use like dot len? Was then like, what is the Pythonic way of doing it? Which is just like, why does that even need to be a discussion? Like some languages get around that by, having things like Go format, where there's a formatter built into the language which is incredibly opinionated and so like takes style out of your hands. But like it's even better if the language syntax just kind of makes that an irrelevant concern.
It's not just the syntax, right? Like for Python, for example, it's about the semantics as well, right? If you call something as a function, or like wherever the symbol is coming from, which is again a thing that you shouldn't really be thinking about when you just want to compute the length of a piece of text.
Yeah, for sure. So what you're showing us, which is really interesting, is the standard library for this language. So all of us as programmers are at the mercy of a standard library or have used a standard library, and you've already spoken a couple of times about things that you're thinking about. Like you said that earlier, that you are designing the standard library from the perspective of like with the visual users first. Like how do you even approach like putting together a standard library for a language? Like how do you approach that design?
Right. So this is a very broad question. So I guess you start with like thinking about what every other language has. Right? Like there is a class of very basic operations that every standard library will have. Like you can do things with numbers, you can do things on text, you can have like some basic sorts of collections, things like that. And then it really helps to like think about a use case for that, right? So like a thing that you would want to do, and then build the minimal amount of stuff that you want to be doing with it. So for example, my first project with the standard library was to get it to a point where I can write a testing framework, because like this really makes my job easier, right? If I'm writing something, if I have a test framework in the language, I can test it already. So my first project was to create a test framework, and then I started from there. Like, okay, so what do I need to have a test framework, right? I need to be able to operate on text. I need to be able to print stuff to the console. I need to be able to like signal failure somehow. So I need booleans and things like that. And yeah, this is sort of the way we prioritize it. Like what needs to be built is a function of what we think the first users will be building with the language.
Right. Yeah. The test framework first thing is actually really interesting. That makes a lot of sense. Like when like in the dev blog, like whenever you do your demo day thing, you're like, hey, this is what I've done standard library. It's really nice actually just be given the test spec and see, like here's all these things working as we're now seeing on the screen. So that makes sense. I now see how that came about.
And also it's a beautiful test framework. Like I'm really proud of it.
Nice. So I think that makes a lot of sense. Obviously there are like just things that every standard library needs. Like you need to be able to operate on strings and numbers and your basic types. Where does it start to get? Are there other like where is the end between like the obvious and like Marcin's personal standard library wish list? Where is that border?
I would say this is a really good question, particularly in the context of the Java interop, right?
Yeah.
Like we pretty much have the essentials at this point. Like we have numbers, we have some basic collections. You can open a file, as I'm showing on screen right now. You can like do a HTTP call. You can parse some JSON and so on and so forth. So like the very basics are there. And then I would say like the standard library for this language is particularly tricky to define because if something is missing, you can just import it from Java.
Right.
So and you can do this seamlessly, and you can do this with good performance. So
be a huge risk of making you so complacent. You're just like, I don't have to worry about that. I'll get to it eventually.
There is definitely is there. But so this is kind of user driven at this point, right? Like we want to get to the data scientists. We have some potential users in data science. So like, for example, the next priority is doing data frames, which are admittedly not a part of the standard library. Like they are a core part of the ecosystem, but they are not part of the standard library per se. So yeah, you just build whatever you need to do at this stage. Right.
Cool. So that was going to be my next set of questions, which is like, we spoke earlier about languages that perform or excel in certain areas, and that obviously influences some of what you see in the standard library. And Enso being a language aimed at data scientists, are there things that, my question was going to be like other things that you're thinking of adding that you wouldn't expect to see, but I guess you just answered that with like things like data frames and acknowledging that they're not part of the standard library. So how, like, again, this is like early programming language thing. We've seen a lot of programming languages nowadays that like come with their own like dependency manager and package bundler and that kind of thing. If data frames, for example, isn't part of the standard library, like how is that going to be distributed with Enso? Like how do I bring in a library or a package?
Yeah, so this is a bit of a challenge right now. So we don't have a package manager yet. All the libraries that we ship, they just come with a magic directory where the libraries go. And like if you create your own package at this stage, I guess what you would do is just drop your package into the directory. Yeah, exactly.
Like the good old days.
But yeah, a package manager is definitely on our to-do list. Again, sooner than later.
Yeah, awesome. Cool.
Because package management is hell in any language. I have never seen a good package manager. This is.
I mean, we started this conversation. We're talking about how you used to be writing this in Haskell, and I think every Haskell programmer has a Cabal horror story or two.
Yes, we do. Like the great grandparent of this project also had like 1,000 lines of Python just to manage Cabal files.
Jesus. Cool. Did we cover all of the growl and truffle stuff that you wanted to show us before I get distracted by something else?
I mean, I can go deeper into truffle.
Please
so like
do.
I can show you
go as deep as you would like. This is your show.
Oh wait, okay.
Oh wow, okay.
Okay, not that deep. So
I wasn't expecting that graph.
So this is
which is a cool graph.
Yeah, this is visual programming with truffle.
Right.
This is an internal tool I use for debugging growl, which is like it's also kind of cool. So I can just show
there's a like, well, I mean, you're about to show it, but there was a really cool. Is this the one we documented in the blog post? The weird bug that you went down. Like the oh god. You know what? Anyway, you keep doing what you're doing, and I'll find the blog post and know what I'm talking about in a minute.
I'm not sure what you're talking about, but this is essentially like my main debugging tool. So like something is not working in the language, this tool is calling into the internals of the JVM and just showing me like what the JVM is doing under the hood. But this is this is just there because I was using it earlier today.
Yeah.
And I didn't listen to you when you said to close unnecessary windows. Anyway,
I did say that. My wonderful guide said that.
If
any of you are ever guests on this show, I send you the best guide. It's like a streaming university in a Google document.
Yes, I at this stage I feel ready to just start my own Twitch channel.
Thank you, Meshek. So the one I was talking about was in our dev blog. We have one of those graphs that you just showed about the call optimization mystery. That was the one I was talking about.
Oh yeah. So you can link that. We did.
It's really cool.
So so this is exactly what it does, right? So like I had a problem that some tail call optimization thing that we have in the language was too slow for my taste. Like I wanted it to be faster. So I just stare into this graph and go like, oh, okay, why is this thing happening? And then track it down all the way through the system. Or no, in that case, it was actually a thing being suspiciously fast. And then I figured out that the compiler figured out that it was my benchmark code, and my benchmark code just was never running because Graal figured out, hey, the value of this code is never used, so let me just not do it.
I found
which is great for a compiler, not great if you are trying to benchmark the compiler.
You know, this is the second time I've had this problem today. we had someone on earlier today who was talking about consistency in blog writing and how important it is to blog regularly. I'm having the opposite end of that problem now, where the Enso dev blog has now been going long enough that I'm finding it really difficult to find a particular thing in it. Because I'm like, oh, that was only like a couple of weeks ago. Nope, that was July. Holy crap. There we go. So it's from that blog I just linked. Adventures in benchmarking and Graal inlining is the heading. It's very cool. So yeah, we're going into Truffle.
Yeah, so Truffle. So what Truffle does is, again, it's a sort of magic. Like if you are interested in programming language design and you have never looked into Truffle, this is your homework. Like this is right. This should be like pretty much any like programming language design 101 tutorial. Okay. So right. What Truffle is under the hood is a framework for writing the interpreter, and you are writing a standard tree walking interpreter. Mm-hmm. So what that means is you represent your program as a tree of nodes. Mm-hmm. So for example, let me show it here. So for example, you have this line of code, right? And you have you represent this as a tree that is like, okay, so there is a variable access, and then a function is being called on it, and then another function is being called on it, and so on and so on. Mm-hmm. And tree walking interpreters are like the easiest way of interpreting programs, the easiest to implement, but at the same time they are the least performant, right? So usually you go through some bytecode or you go straight to machine code. A tree walking interpreter makes your language slow. Mm-hmm. Unless you implement a good JIT for it. And this is what Truffle does. So what I'm implementing in Truffle, so we are in a node that's called read local variable node. And it does what it says on the tin, right? You just when you execute this node, you look into the current execution frame, so like your bag of available variables, and you pick the one that you are looking for, right? Mm-hmm. And it's like some pretty uninteresting code with a lot of special cases that are checking like, oh, is this value a primitive number? If it's a primitive number, then we can probably do something faster, and so on and so on. So normally that would be pretty slow, like not terribly slow. It would be like on the level of C Ruby.
Okay.
What Truffle does with the help of Graal and the fact that Graal can allows you to call into the JIT compiler is Truffle will take this code, the user code, and pass it to the Java compiler. So the Java JIT compiler will then go through the user's code and simplify it. Mm-hmm. So we have a tree walking interpreter where, for example, like a tight loop that's going through a vector and like adding numbers in the vector.
Yeah.
This is working as fast as it would work in C, just because there is like when the system warms up, it just goes into the mode of it's actually emitting the assembly, the same assembly that the C compiler would emit for an equivalent code. Yeah. And you get all of that for free, which is like just unbelievable to me, right?
Yeah.
Because even for writing interpreters, there's a lot of tasks in tree walking interpreters that are very common. This is pretty much the whole thing that sparked the existence of Truffle, right? Like people realize that, oh, hey, actually, when you think about it, the JS runtime, the Ruby runtime, the Python runtime, they all like repeat a lot of different tasks. So they hosted those tasks into a separate framework and then added JIT compilation on top of that.
Yeah.
So I'm fascinated by Truffle. It's
that's super neat.
It's
technology. Are there other programming languages or like already out there that have Truffle implementations that are like written in Truffle? Like, is there any industrial language currently being used that has like a Truffle interpreter now?
So about languages that exist, there is an implementation for JS. There is an implementation for Ruby. There's an implementation for Python and R. And also on top of that, there are interpreters for LLVM bytecode and for WASM.
Which then makes basically everything work.
Yes, exactly. So like you can compile your Rust to WASM or to LLVM and then run it on top of Truffle, which is also pretty cool if you ask me, right? Like that you can run WASM code on the JVM. And it's cool. Also like there is pretty much no performance overhead on top of that. Yeah. About that being used in production, I'm pretty sure that it's possible right now to migrate a Node.js app into Truffle, like into Graal.js.
Interesting.
And I think JS is the most like feature complete implementation of a Truffle language. So at this stage, Ruby, for example, has a bunch of problems with different gems. I know that people are actively working on pushing it to production. So for example,
because like
I know that
JRuby was one of the bigger Rubies anyway, so like a Graal Truffle Ruby makes perfect sense.
yes, exactly. And I think Truffle Ruby is at the like it has feature parity with JRuby, maybe something like that. I know that, for example, one of the original creators of Truffle Ruby. So the whole project, Graal VM, and like all the languages are managed by Oracle. One of the main creators of Truffle Ruby is now working at Shopify at Shopify, and Shopify is kind of like
one of the bigger Ruby shops in the world.
Yeah, exactly. And they are trying to productionize Truffle Ruby because they are having performance problems, right? Because the story with Ruby is really fascinating because it's a great language to start your product with because you get to an MVP so quickly and then you reach end users where N is not that large for a startup, for a successful startup.
Tell it to GitHub.
And you are facing a rewrite at this stage, right? Like this is what Twitter did, for example. I think Twitter was written in Ruby, and then they just moved to Scala because Ruby would not scale.
Yeah. But then they moved off Scala eventually as well. But I can't remember what the story is with that. That makes sense. I was going to ask you something else about something you just said, and I immediately forgot what it was. Never mind. That makes sense. And like I think we had a conversation at some point, or I was listening to a conversation at some point that you were having. That was probably the more likely situation where, like, if you want to talk about performant language virtual machines, like really, like there is no current virtual machine that's like more battle tested than like the Java ecosystem of virtual machines. So if you can get like the programmer efficiency of our other programming languages onto like that ecosystem, you get just like such a wealth of benefits for free, which I guess is what people like Shopify would be trying to do.
Definitely, like if you are going to trust a virtual machine, I would trust Java virtual machine, and I pretty much do, right? Like probably all
we better if there's a third stack in a year's time, if we're doing the show again, be like, okay, what's it like to move from 2 stacks to a new one?
No, I'm not talking about like I trust Java with Enso. I just like. Among the language runtimes, I would say that the JVM is probably the most battle-tested one, right? Like all the banks, everything is working on Java. So like, it's really important that Java doesn't break.
Yeah. So
which is not true for
being trolled in the Enso Discord. Excellent. Cool. So we are running close on time. So I wanted to make some time to talk about the project. So I guess what I want to start with is like, and I know this is a difficult question to answer at this particular place in. Actually, yeah, let's go with that. Where is Enso in its development cycle right now? Like, what you've gone from this process of like, hey, there was Luna, it was something you could download, to now rewriting it. Like, where is it right now?
Right. So there's 2 parts to that answer. So Enso, the interpreter, I would say at this stage is just simply better than Luna ever was. So like we have full feature parity with Luna and then some. So the language is much better. The ID we are releasing it right now.
I would have a panic attack.
Go download. The IDE is in a pretty interesting shape right now. So I was actually like looking into it in the past week, and they have implemented like most of the core functionality of connecting nodes and so on. There is still some bugs in that system. There's some junk, just because WebGL is hard. Like it's more difficult to implement things in WebGL than it is in HTML, right? So Wojciech, who's in chat, he's like implementing some sort of bizarre magic to make that all work and make it workable. But it still breaks sometimes. And also, I don't think we have matched the level of available visualizations that we had in the previous system. So right now, the set of visualizations is pretty small. But again, this is something that's going to change in the coming few weeks. So close to release.
Where's the cool. Yeah, it's actually pretty easy to add visualizations. I think you said earlier that like visualizations you can add them just in like JavaScript and HTML, like in web technologies. It's pretty easy. They go fast.
Yes, it's a plug and play system. I think someone can post it. And yeah, if you want to play with either the language or the IDE, you can download a version from our GitHub Actions. So like, be warned that it's not a product that we are bragging about just yet. It still requires a lot of love, but there's things you can do with it. And particularly, like I'm working on the interpreter, so I feel more confident speaking to that part.
Sure.
I would say you can probably try and do a thing with the textual language. I would actually be thankful if someone like wanted to test it and report bugs. Because like one interesting thing that happens to you when you implement a programming language, you don't know when it breaks.
Right.
Because you have built the thing, so you kind of like I kind of have my own paths through that. Right?
This is giving me PTSD to when I tried to film that video for Luna like 1.8 or something like 2 years ago.
Yeah.
And I immediately was like, oh, that something's broken, and you were like, oh, I know my way around that. It's just like, oh, okay.
Yeah, it's just it just naturally happens, right? So like a great thing that's happening in the standard library team right now. It's actually happened a few months ago. Started happening. A person from our team that was not involved with the language implementation at all started building parts of the standard library. And the number of like bugs and counterintuitive behaviors they are reporting is just great, right? And those are things that I never thought to test even, or like I thought to test them at some point, but then like I kind of forgot they existed because I know how to write this code well. If you don't know that, you are going to break the language.
Yeah, for sure. So the reason I wanted to ask like where Enso was at the moment was because I was going to ask if people are interested and want to contribute, for example, what should they do and where they should go. And the reason I wanted to set you up for that was because I know that, for example, we're seeing 174 issues, but Enso does work in the open. So like a lot of those issues are like you and the team working basically internally but externally visible, so they're not necessarily set up for external contributors. Are there any parts of the interpreter right now where you're like, that's an easy place for someone to dive in, or a less hard place for someone to dive in?
I don't think.
And it's okay if the answer is no, because there is on the IDE side, and I can show that.
Yeah, so I don't think that we have issues yet, but this is really a shame, and we need to get better at it, because now there's a standard library, now there's like a bunch of bugs that you can be fixing, a bunch of functionality you could be adding. So I pinky promise to open a few issues this week for the Enso repository.
Awesome. And yeah, I'll quickly still screen share for a minute, because to answer that from the other side, boop. There we go. So there is some Hacktoberfest issues on the IDE side, which, as Marcin said, is Rust and WASM. And two of these are currently claimed, but there is one that's still free. So Farmazon and Wojtek spent some time at the beginning of Hacktoberfest trying to basically, as I just said, like the team is in a place where there's like very heads down on like core functionality, so it's been challenging to externalize some issues or make some issues available, but they did manage to do that with some things that are good beginner stuff. The last remaining Hacktoberfest issue on the IDE is unfortunately the one that's marked as intermediate, which is this crash reporting issue, which it's still not terrible, and it's pretty well specified. And if anyone is interested at taking a crack at that, drop a comment and we will help you out. Wojtek spent some time this weekend with one of the contributors on the other issues. We have a really active Discord, which is discord.gg/Enso, and the team will be able to help you out if you do want to dive into that issue and have a little go at doing some Rust and WASM stuff.
I love this vanity URL we have now.
I know, it's so good, right? Verified Discord servers. Pro tip, open source maintainers out there, Discord will verify you if you're an open source project. You don't need to anymore because there's community projects. But we got it when it was still a thing that was worth having. Cool. Awesome. Well, I have run out of questions, stuff I want to talk about. Is there anything you wanted to mention that we haven't covered?
No, I don't think so. I think we've shown everything, or at least
everything that's currently
places for people to dig into if they are really interested in it.
Yeah. So I posted a couple of links. Obviously, Discord was the last one. You'll also see 2 links from dev.enso.org. That's the internal developer documentation for Enso. And so the top one is, if you want to try Enso now, after all the disclaimers about stuff being a little bit broken, you can go do that, and it's fun. And as Marcin said, you can download the actual distributions from the GitHub Actions and the stuff in there. And also, I also shared the link to the visualizations, which shows you how to define visualizations. And also, for those of you who know me and have been a victim of my engineering work before, that dev.enso site is a patented Joe Nash Jekyll site, and it is jank. It is terrible.
It's still great. Like it's still better than browsing documentation on GitHub.
I still need to fix the dark mode bug in the search bar, but we'll get there. Anyway, thank you so much for coming on the show and talking about Enso and getting in deep on truffle stuff. I'm actually I need to do that truffle implementing a language tutorial because it does look super fun. And I guess I've already spoiled.
There's no tutorial.
Didn't they do like a...
The implementing a language tutorial just tells you to go to a repository and clone it and have some fun with it.
Here I was being like, that looks like a fun tutorial, and you've just burst my bubble in the worst way.
One complaint would be this project, like Truffle, is not really... Like, it doesn't have tutorials. It doesn't have... Right. There's one blog post series. I may actually post it if I find it.
Yeah.
But anyway, yeah, like, if you think about it, how many users are there for a framework for interpreting programming languages, right? Like, not that many. So they are not really investing in, like, super friendly documentation.
That's true. And it's Oracle, so not known for their documentation.
Yeah, so it's this blog post series. Am I allowed to
send it to me in the private chat on StreamYard, and I'll post it, and otherwise you'll get yourself banned.
Okie doke.
Perfect. There we
go.
So
this is a blog post series, like four nice blog posts that show you how to implement a very simple Lisp in Truffle.
Oh, that's cool.
And this is probably as close as it gets to like an introductory tutorial to the whole system.
That's awesome. Super cool. Awesome. Well, thank you for sharing that, and thank you for spending time with us today and walking us through all of those wonderful things. I shall free you from your StreamYard prison now and do the backstage shuffle. So again, thank you so much, and enjoy the rest of your evening.
Thank you. Bye.
Alrighty, thank you, Marcin, and I hope you all enjoyed. Thank you, Wojtek, for being in the chat and answering questions from our viewers. Thank you, Maciek, for that as well. That is everything from me today. That's the end of our show. Stay where you are. Let me run you through the schedule for the rest of the week. So as I said, we have 3 more days of 3 shows a day. We have 9 shows left, and you can find our full schedule at twitch.tv/raisedevs/schedule. Let me give you a spoiler of what's to come. So the first thing to say is 9 shows, 3 shows a day is a lot to keep track of. You don't have to keep track of that. Computers will do it for you. All you have to do is go to twitch.tv/raisedevs. There's that 11 p.m. brain fog kicking in. Twitch.tv/raisedevs and hit the follow button. Hit the little love heart and then hit the bell, and you'll get notifications whenever we go live. You can also subscribe. You can also follow us on Twitter, @raisedevs, and that will we tweet an hour before every show, so you'll know exactly when we're going to go live. So onto that schedule. Let me give you a spoiler of what's to come. So, tomorrow morning, we have Matt Cowley, the community platform manager at DigitalOcean. If you've been involved with Hacktoberfest or you've been paying attention, you will know Matt as the person who maintains the Hacktoberfest app. He's back with us again tomorrow. We're not talking about Hacktoberfest tomorrow, we're talking about his other job, because maintaining Hacktoberfest isn't enough work, so he also works at CDNJS. So tomorrow morning, we're going to be talking about CDNJS, which is a big content distribution network for the JavaScript ecosystem. So it maintains a good deal of the web. So we're going to talk about that and diving into the code for that. We'll then have Ramon joining us. I think he's still in the chat. Are you still here, Ramon? This is like the 3rd time I've done this to you today. You've been in all of our shows today. Thank you so much. He's doing his research. He's preparing for me tomorrow. So tomorrow, the second show of the day, we have Ramon coming on. Ramon's the Rubyist. But tomorrow, we're doing our favourite game, which is the old code game, where we ask a viewer to bring something they worked on in the past, and we review it in terms of what they know now and what they would do differently and how they've grown since. Except Ramon's bringing us a really fun project, which is a Raspberry Pi dance mat controller. If you remember the old like dance mat games, like PlayStation 1, it's like a Raspberry Pi controller version of that. And it still works, apparently, and it's in JavaScript. So we're going to be looking at that. That's going to be hilarious. The last show of tomorrow is with Angel Rivera from Circle CI. That's going to be hosted by our founder, John. And that's going to be all about Circle CI. Well, not all about Circle CI, sorry, all about CI in general. So also, yes, Circle CI. All about CI in general, why developers need CI, how CI, what CI. Those kind of good things. And that'll be great fun. John and Angel will do a great show. Thursday is Guanluca. Guanluca is on the special interest group for releases for Kubernetes. So Guanluca spends a lot of time working on making sure that releases of Kubernetes are good quality. They get out to everyone they should do, that kind of thing. And so that's going to be an episode where we talk about ways you can contribute to open source projects that aren't necessarily code. We're going to be talking about the release process and how you can help the release process of your favorite open source project. The next show on Thursday is Nathaniel from Twilio. Nathaniel's a developer evangelist at Twilio in London, and we're playing the old code review game. Nathaniel has his first JavaScript project from university, which is going to be super good, because my favorite thing about doing the old code review game for JavaScript is not only have their ways of programming changed, but the language has also completely changed, and standards we used then are no longer standards. So that's going to be great. The last show for Thursday is Sam Lanning. They're an engineer at the UN, or they work at the UN rather. And we are, again, playing the old code review game with Synesthesia, which is a project that Sam made to control lights and music in festivals for installation, like art installations at festivals. Really wild project. We've got a lot of wacky hardware projects coming on the show this week. I'm very excited. That's also hosted by John, so John will be hosting that one as well. Friday morning, got Nicholas Carrigan. Nicholas has been a regular fixture in the chat in our show. He's been hanging out with us all month, so we had to get him on the show, and we're going to be doing some code review with Nicholas. Then we've got Eddie. Eddie's an open source advocate who spends a lot of time on Twitch and on YouTube helping people get into open source. He produces great content. He was with us on the first day of this stream where we kind of like set up Hacktoberfest and spoke about what Hacktoberfest was. He's coming back to have a little bit of a rest and reflection on how Hacktoberfest has gone. Talk about what he's been up to during Hacktoberfest and give some final tips for the people who are going to be spending that last day trying to get their pull requests in. And then the final show, this Twitch channel is basically Coachella. I'm going to like put that quote on our Twitch page. Thanks to you. The final show could not be bigger. The final show of our Hacktoberfest Twitch streaming marathon, we are getting our own Chris Ewald. Chris is a developer here at Raise.dev and also a coach at Raise.dev. And we're getting Matt Cowley. Why do we have these two people? Well, Chris, a couple of years ago for Raise.dev, built the Hacktoberfest app. He built the app that runs Hacktoberfest. Matt is now the current maintainer of the app that runs Hacktoberfest. So we're going to have a old maintainer, new maintainer situation where we talk about the app that makes it all happen, talk about what Matt did then, what Chris did then, what the constraints were then, why he did the things he did, what Matt has had to change, what hasn't worked, what has worked, what Matt would have done differently. Their forces combine. It'll be a great show to finish and wrap up this Hacktoberfest. So that's all from me for right now for our schedule review. Again, drop us a follow on Twitch. You'll get the notifications when we go live. And the final thing from me, if you haven't already, highly encourage you to sign up to Race.dev if you are looking to take the next step in your developer career, whether you're trying to get your first developer job after a bootcamp or after a career change, or whether you're trying to level up, learn how to mentor junior engineers, something like that. We have expert coaches who will work with you towards your goals. They'll meet with you regularly. They'll pair program with you on projects. And we are completely free right now whilst we're in early access. And you can find all that information at Raise.dev. So thank you again so much to our guest, Marcin. Thank you all for hanging out in chat. Thank you for also answering questions in chat, Wojtek and Meshek. And that is everything from me. I hope you enjoy the rest of your evening and that we see you tomorrow. And if we don't see you tomorrow, I hope we see you sometime soon and you have a wonderful time until then. Thank you so much. Goodbye.